that the world you perceive around you isn't as it seems, that it's governed by rules and principles that defy our everyday understanding. Welcome to the world of quantum mechanics in 3 dimensions. At the heart of this fascinating world lies the concept of quantum mechanics, a branch of physics that examines how particles like atoms and photons behave. A cornerstone of quantum mechanics is the notion of superposition. This principle tells us that a particle can exist in multiple states at once, only settling into a single state once observed. Another key principle is wave-particle duality. This idea suggests that particles can exhibit properties of both particles and waves. Now imagine these principles in 3 dimensions, just like how we experience our world. It's not just a flat plane. Particles move and interact in all directions. So that's the basic premise of quantum mechanics in 3 dimensions. But how does it actually work, Lee? To understand quantum mechanics in 3 dimensions, we have to get to know the actors on the stage, the quantum particles. The quantum world is a bustling stage, with particles like electrons and photons playing important roles. These particles, while infinitesimally small, are essential characters in the quantum story. They have properties and behaviors that are far from what we're used to in our everyday world. Take electrons, for instance. These tiny particles, which orbit the nucleus of an atom, possess a property known as spin. But don't be fooled by the term. This isn't like spinning a top on a table. In the quantum world, spin is a type of intrinsic angular momentum, and it's a key player in the magnetic properties of atoms. Then we have photons, particles of light. These little guys can perform a magic trick known as quantum tunneling. In our everyday world, if there's a wall in front of you, you can't simply pass through it. But in the quantum realm, a photon can find itself on one side of a barrier and without having to climb over it, suddenly appear on the other side. This behavior is not due to a lack of respect for the laws of physics. Rather, it's the result of probabilities and wave functions, a tantalizing taste of the weirdness that is quantum mechanics in 3 dimensions. Now that we've met our quantum actors, let's consider how they interact with each other. Quantum particles in 3-dimensional space don't just exist in isolation. They interact with each other, leading to some truly mind-bending phenomena. So, what's one of these phenomena? Let's talk about quantum entanglement in 3 dimensions. Quantum entanglement is like a cosmic dance where particles become inextricably linked, no matter the distance between them. It's as if 2 dancers, miles apart, perfectly mirrored each other's moves instantaneously without any visible connection or communication. This might sound like science fiction, but it's a fundamental aspect of quantum mechanics. To visualize this in 3 dimensions, imagine a pair of entangled particles situated at opposite ends of a vast universe. Despite their vast separation, a change in the state of one particle triggers an immediate response in its partner. This interaction, this dance, happens faster than the speed of light, defying our conventional understanding of space and time. But how do these particles become entangled in the first place? It often happens when they are created at the same time and place, like twins separated at birth. They remain connected, mirroring each other's states no matter where they end up in the universe. The implications of this are profound. It suggests a deep underlying connection between all things in the universe, a connection that exists in the very fabric of reality itself. Quantum entanglement in 3 dimensions is just one of the many strange and fascinating aspects of quantum mechanics. So what does all this mean for us? Why should we care about quantum mechanics in 3 dimensions? Well, it's simple. Quantum mechanics doesn't just exist in theory. It has real-world applications that are changing our lives as we speak. Take quantum computing, for instance. While classical computers use bits, quantum computers use quantum bits or qubits that exist in multiple states at once. This allows quantum computers to process information at an unprecedented speed. Then there's quantum cryptography, a method of secure communication that uses the principles of quantum mechanics. This technology could revolutionize our world by providing us with unbreakable codes, ensuring our data is safer than ever before. Quantum mechanics also plays a critical role in understanding the behavior of atoms and molecules, which is fundamental for advancements in chemistry and material science. Quantum mechanics in 3 dimensions might seem strange and counterintuitive, but it's the key to understanding our universe and potentially unlocking technologies of the future. So next time you look around, remember, there's more to the world than meets the eye.